And this one says the electric field of a plane electromagnetic wave is given by vector E is equal to E naught x cap plus y cap sine kz minus omega t. Its magnetic field will be given by. So the question is from the topic electromagnetic waves. We have the expression for the oscillation of the electric field, and we see that the wave is propagating along the positive z axis. What is the expression for the corresponding magnetic field? Let's start our solution, and if I draw the two axes, the x and y axis, let's say something like this, okay, we see that the electric field oscillation is happening in the xy plane, and the wave is propagating along the z axis, the positive z axis. It means that the magnetic field is oscillating also in the xy plane only. Let's assume that at some instant sine kz minus omega t is 1, and at that moment the electric field vector is given as E naught x cap plus y cap. That means it is directed like this. Since it is x cap plus y cap, this angle is 45 degree, right? So this is the direction of the electric field oscillation. In fact, the amplitude is root 2 times E naught, okay? So this is at that moment the direction of the electric field. Now E cross B is the direction of propagation of the wave. The wave is traveling in this direction, the positive z direction. So combining these concepts, that means the magnetic field is oscillating in the xy plane. It is perpendicular to the E vector, and E cross B is in the direction of the positive z axis. Means that the magnetic field vector at this moment should be drawn like this, right? This is how the magnetic field vector is to be drawn. This angle is going to be 90 degree. Well, the unit vector in the direction of the propagation of the magnetic field, in fact, is minus x cap plus y cap divided by root 2. So that's the direction. What about the peak value of the magnetic field? The peak value of the magnetic field is given as peak value of the electric field divided by C. With all this, we have the expression for the magnetic field vector as E naught by C into the direction of propagation is given as minus x cap plus y cap into sine kz minus omega t. I hope that is clear. And if we look at the options, we have E naught by C minus x cap plus y cap sine kz minus omega t as the value, in fact, the expression for the oscillation of the magnetic field. So option 3 is the correct option. Let's go to the next question now. This one says find the binding energy per nucleon for tin whose atomic number or the proton number is 50, the mass number is 120. Mass of proton has been given in terms of atomic mass unit, mass of neutron is also given, and mass of the tin nucleus is also given to us. We have to find the binding energy per nucleon for this particular nucleus. Well, the expression for the binding energy per nucleon, so there are 120 number of nucleons here. So binding energy divided by 120, this is what we are supposed to find. What about the binding energy? This is equal to the mass defect into C square. So what is the mass defect here? Well, there are 50 number of protons and 70 number of neutrons. That's very clear. So that means 70 times mass of neutron plus 50 times mass of proton minus the mass of this tin nucleus, which is, let's call it MSN. In fact, that is how it has been called in the question that is given to us. So this is the mass defect. We need to multiply it by c square, the speed of light square, divided by 120. Now all the values are provided to us. In fact, since we are going to get mass defect in terms of U, so we need to multiply that quantity by 931 mega electron volt by C square. So we will get it in terms of mega electron volt, and then we need to divide it by 120, and if we perform all these calculations, the binding energy per nucleon comes out as 8.5 mega electron volt. That means option 2 is the correct option. Let's go to question number 6 now. And this one says a quantity X is given by IFV square divided by WL to the power 4 in terms of moment of inertia I, force F, velocity V, work W and length L. The dimensional formula for X is same as that of, and the 4 options are given. Clearly the question is from the topic units and measurement, and specifically on dimensions. Let's write the dimensional formula for each of these terms and simplify the term to find what quantity has same dimensional formula as what we are getting after simplifying this. So the dimensional formula for moment of inertia is mL2. So mL2, that's for moment of inertia. For force it is mLt minus 2, and for velocity square it is L2t minus 2. So this is L2t minus 2, and then we need to divide it by the dimensions of W and L4. So W, in fact, the dimension of work is mL2, t minus 2, and of course there is L4. So we need to simplify this, and if we simplify this, this comes out as equal to m L minus 1 t minus 2, right? And this in fact is the dimensional formula for energy per unit volume. Energy is mL2t minus 2 divided by volume, that means divided by L3, has same dimensional formula as this one, and that means among the options, the third option, energy density, is the correct one. Let's go to the next question now.